Okay, here I will give few examples basing on the order and degree. Okay, this is one example they given. Sorry, d power 4y by dx power 4 plus 7 into dy by dx whole cube plus x equal to 0. This is the first example. Okay, d power 4y by dx power 4 plus 7 into dy by dx whole cube plus x equal to 0. So here what about the, for this differential equation we have to calculate order and degree. What is the order and what is the degree? So here what is the highest derivative involving here? D power 4y by dx power 4. So this is the highest derivative involving in the given differential equation. So order is equals to 4. Now degree. When we are discussing about the degree, first we have to cross check. Is the differential equation is free from the fractional powers? Means you have to cross check. Is there any fractional power? No fractional power. And is it in the polynomial form? Yeah, it is in the polynomial form. Now here the power of the highest derivative. Here the power is nothing but 1 is there. So the degree is 1 is the value. One more example. Write up one more example. Here the example they given y double dash whole square equal to x cube into y dash whole power 1 by 3. If they given like this, here don't confuse y dash. Here the y dash means nothing but dy by dx. Instead of writing every time dy by dx, simply I am writing y dash is the value. So here if you observe, what is the order and what is the degree of the differential equation for this equation? So here the highest derivative y double dash is there. So order is equals to 2. Not an issue. So directly you can say order is equals to 2. What is the degree? For degree, first you can cross check. Is any fraction powers are there? Yes, it is. Here the fraction power 1 by 3 is there. So if possible, the first step is remove that fractional power. We have to make the differential equation free from the fractional powers. Means we have to remove that fractional power. So 1 by 3 is there. Cubing on both sides. If I cubing on both sides, here I can get y double dash whole power 6 equal to, this is the 9 I can get, here it is y dash. So here after simplifying like this, then this is in the form of the polynomial equation which is free from the fractional powers. So automatically you can say what is the degree of the differential equation? Degree is equal to 6 is the value, since this is the highest derivative. The highest derivative power is 6. So automatically 6 is the degree of differential equation. One more example. Here they given third example, y dash equals to 1 by y dash minus y. This is the value they given. Y dash equals to 1 by y dash minus y. So first of all, we have to form in a differential equation, means in a polynomial equation involving differentials. So here if you observe, here if you simplify, I can get y dash plus y equal to 1 by y dash. Then cross multiply with this y dash. Then I can get the equation as y dash whole square is the value, y dash whole square plus y into y dash equal to 1 is the value. So this is in the form of the differential equation, that too polynomial differential equation free from the fractional powers. Then automatically what about the order for this differential equation? Order is equals to the highest derivative involving here it is y dash only, means one time only, order is equals to 1. Then what about the degree of the differential equation? Degree means the highest derivative, power is the value. What is highest derivative power? It is 2 is the value. So degree is equals to 2 is the value. One more example I will write. Here they given e power y triple dash minus x into y double dash plus y equal to 0. This is the value they given. Okay, if you observe here, the example is e power y triple dash minus x into y double dash plus y equal to 0. So first of all, here for this one directly, what is the order of the differential equation? If you observe, order equals to y triple dash is there. Y triple dash means order is equals to 3. Then what about the degree of the differential equation? In order to discussing about the degree, first of all, it is free from the fractional powers. So of course, here there is no fractional powers. Okay. And one more important point is, it should be in the polynomial equation involving differentials. Here e power y triple dash is there. You can't express as the polynomial equation differentials. First of all, here I am using polynomial. What does that mean, polynomials? Means f of x is equal to some x power n plus a1 into x power n minus 1 plus a2 into x power n minus 2 plus up to so on an is equal to 0. This is known as the polynomial equation of nth degree. So in order to explain the degree, the differential equation should be in the form of polynomial equation involving differentials. But here e power y triple dash is there, so it is not in the polynomial equation involving differentials. So automatically for this, degree is not defined. Degree is not defined like this. One more example I will give. Here if I will give next one more example, here it is sine inverse of dy by dx equal to x plus y. This is the next example. Sine inverse of dy by dx equal to x plus y. What about the order and degree of this differential equation? So here if you observe, I can write this value. I will modify the equation as dy by dx is equals to sine of x plus y. So this is in the proper form only. Here dy by dx equals sine of x plus y, but of course sine of dy by dx is there, then degree is not defined. Here sine of x plus y is there. These are the variables. So it should be no problem. It will be like this, no, not an issue. Then what about the order for this differential equation? If you observe, order is equals to 1. And what about the degree for this differential equation? First highest order derivative 1 is there, its power is 1 is there. So degree also equals to 1 only. With one more example I will give. Okay, here one more example I will give. Here the one more example is d cube y by dx cube equal to x into logarithm of dy by dx. This is the example. D cube y by dx cube equal to x into logarithm of dy by dx. So first of all, for this one, order equals to, what is the order of differential equation? 3. Since highest derivative involving in the given differential equation is 3, so the highest derivative is 3 means order is equal to 3. Then degree. In order to say degree, we are discussing about the degree. But if you observe degree, when we are discussing about the degree, it should be in the free from the fractional powers and it should be in the polynomial equation involving differentials. So here if you observe, this is the free from fractional powers, that is okay. But here, is it in the form of the polynomial? No, log of dy by dx is there. So here this is not in the form of the polynomial equation involving differentials. So automatically degree is not defined. Degree is not defined. For example, instead of this dy by dx, if logarithm of some x is there or logarithm of y is there, then you can say degree also. But here logarithm of dy by dx is there. If they given like this, then automatically degree is not defined. Okay. One more example I will give. Here the example is logarithm of y dash equal to ax plus by is the value. Logarithm of y dash, of course to the base e is there. Logarithm of y dash equal to ax plus by. What is the order and degree of the differential equation? So for this one, in order to say the degree, not an issue, simply y dash is the highest derivative involving in this differential equation is 1. So directly you can say order is equals to 1. Then what about degree? In order to say the degree, we have to modify the given differential equation. It should be in the form of the polynomial equation involving differentials. So here I can write y dash, here it is y dash equal to e power ax plus by. Can I write like this now? Y dash equal to e power ax plus by. Then here y dash equal to e power ax plus by means here x is variable, y is variable. This side not involving any differential. So it is in the form of the differential equation. That too polynomial differential equation. So automatically degree also we can say. What about the degree of the differential equation? So degree means the power of the highest derivative. Here y dash, this is the differential. What is the power of this value will be? 1 is there. So degree is equals to 1 is the value. Okay. Thank you.